It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, my co-host Andy Grabner is making fun of me during this intro. He's got a lot of lanyards hanging behind him, which reminds me of, when I was young, all the quote-unquote cool kids would keep on their wristbands for when they went to different clubs or went to see different bands to try to prove how cool they are. So now everybody, if you're seeing that picture and they're in there, you can see how cool Andy thinks he is. That was my attempt at recovering from my malaise this morning, Andy, to review.
Yeah, I'm not sure if conference badges are something to be,
they're kind of cool.
So some of them are kind of, but to be
you
proud of.
You meet a lot of really cool people, and all of our guests are, right?
That's true, yeah. But you don't only meet great people at conferences or at running events. You also meet them.
No, you don't. Where else do you meet them? Oh my gosh, where?
For instance, at a university.
Oh.
Like at a research lab.
Yeah.
Or in an organization that happens to have a research lab at a university. Wouldn't it be cool if you would just meet people there and then they would even be open to have a discussion on a podcast about what they do?
Sure would. I wish that could happen, though. I don't know how we could make that happen, though. Is there some secret you're holding back on me, Andy?
Well, maybe we need to have a magic wand. And, I think we're doing a really bad attempt of being funny today. So I think we just... Yeah. We have two guests today on the podcast, Otmar and Martin. Thank you so much for being here. I would like to quickly start with Otmar. Otmar Ertl, I have your LinkedIn profile open. It says Senior Principal Software Mathematician and Head of Real-Time Analytics Research at Dynatrace. That's a mouthful, hard for me to pronounce. Can you quickly introduce yourself, what you have done in the past and what you do right now in the research lab?
Yeah, actually, it's very interesting because I have a master in physics and not in mathematics. So it's this title was given to me at some point by Dynatrace, but it's a long story. Anyway, so as said, I have as background a master in physics, did a PhD in technical science at the University of Technology of Vienna. And I was working along in the field of computational physics. So there's already the intersection between mathematics, physics, and computer science. And after that, I had 2 years in automotive industry developing simulation code. And then I switched to Compaware, which was then Dynatrace again. Mm-hmm. And I'm with Dynatrace since 2012, so it's already a while.
Yeah,
and worked for more than 8 years in development, building root cause analysis and anomaly detection from more or less scratch for the second generation. And in 2020, I switched to the research lab. So this is where I'm now. Yeah.
Cool. That's a great story in history. And maybe update your LinkedIn profile and Master in physics sounds really, really good and impressive. Martin, to you, if I look at your profile, GenAI lead and tech evangelist, Dynatrace, head of generative AI research, ex-Microsoft, ex-CERN, machine learning researcher, data scientist, and then a brief DOS PhD. I think I'll let it to you to explain what this all means and where you come from.
Yeah, I think I pretty much used up all the character limit on this LinkedIn description. Sorry for that. Like Otmar, actually, my background is physics. I have a PhD in particle physics, actually. Unlike Otmar, I'm still relatively new at the company at Dynatrace. I've only been around for 1.5 years or so. I spent quite a lot of my time actually in academic research in particle physics together with CERN, as you've already mentioned. Mm-hmm. What I've been doing there is analyzing data with machine learning. So pretty much what I'm also doing now, just very different kind of data and also very different kind of interpretations of outcomes perhaps. But a lot of the day-to-day work and the tools and so on are actually pretty similar. Yeah, after a few of these typical academic position stations, I switched to industry a couple of years ago in 2019. I was at Microsoft for a couple of years, working on speech recognition and language modeling. And yeah, now since 1.5 years, I joined Dynatrace and started building up essentially this department in the research lab on generative AI research.
Wow.
Talking about CERN.
I was going to say, I think it's safe to say that we're smarter than them, Andy. Kidding.
Absolutely.
Not at all.
Well, I don't even think if we add our two IQs together that we would beat them individually,
But you're going to talk about CERN, right? Because
CERN, yeah. So Martin, I'm not sure if you knew, but just 2 months ago, we had Ricardo Rocha from CERN on our podcast because I saw him present at KubeCon a while ago. And then I asked him, hey, do you want to jump on the podcast to discuss how much data the Large Hadron Collider is actually collecting and how they're processing the data. And that was really interesting. And what they're doing with Kubernetes and how they're using Kubernetes to really distribute the load. So there was a really interesting and engaging discussion with Ricardo. I'm not sure if you are familiar with him.
I don't know him, but yeah, I know, of course, what's going on at CERN and with data processing. And I mean, a lot of stuff. We did something like cloud computing long before it was cool, actually. Yeah. So yeah, it's always at the forefront. It was very, very exciting times in every respect, not just the physics aspects, but also socially, technologically, and so on.
Yeah. Hey, so the idea of the podcast and the topic came actually up when Otmar and we had a chat, because I think Otmar, I saw some of your presentation, one of the presentations that you did on a different topic. But then we started talking, how can we make some of the stuff that you are doing and working on more public? And then you said, you know what, we're working at the research lab, and for a company of the size and the geographical region we're in Europe, it's actually very unusual that there is a research lab at a university. And then I said, you know what, maybe that should be the topic, that we talk about the research lab and the work that has been doing there, kind of the intersection between research and then taking what's been researched there and bringing it to the industry. I'm not sure if you want to kick it off, or Martin, but I would like to know a little bit about the history of the research lab. I think you mentioned you started in 2020, but can you give us a little bit of a background, the history, and how it grew and where it's going?
Yeah, I can say some words. Actually, I was not involved when the original idea was born. This was maybe in 2018 or 2019, but I was asked in 2019 if I'm interested to join the lab from the very beginning. So this was very exciting. So the basic idea was, we had a reasonable size, and so we could also, look more into the future, what is relevant and for the product maybe in the next generation, after the next generation. So this is what we called, I think, the N+2 approach at the very beginning. Mm-hmm. So if N is the current product generation, then N+1 is what development is working on, and N+2 would be then the topics what we are looking into, and which might or hopefully are relevant in the future product generations. And
so that means really it's a nice way of putting it. And you said a reasonable size. We talk about our employer, we talk about Dynatrace. Dynatrace at a reasonable enough size to say we're dedicating a certain amount of people or money, resources, whatever you want to call it, to research on what's next after next.
Exactly.
Cool. I think also when we were sitting down together yesterday at the lunch table, we also had Andreas Hametner sitting there. Can one of you just quickly say what his role is? Because I just saw him in a video that is promoting the research lab. Can you? I know he's not here today, but if any one of you would just quickly highlight what he's doing.
Yeah, he is the lead of the research lab, so the organizational head, both of the physical entity. I mean, we have this co-working space, or a part of the co-working space at the JKU, right? But also of the unit, of the department within Dynatrace. And yeah, he's been involved since the beginning. So essentially, he created the whole of at least played a major part in creating the whole mission statement and deciding what topics to work on and initial recruiting. And yeah, is still, of course, heavily involved in all this.
And so you mentioned 2020, maybe the initial idea came up 2018. Can you give us some idea? Are there 5 people, 10 people? What are we talking about? How big is this research lab right now?
Currently, I think we're around 20 people distributed, mainly in Linz and Vienna, but we also have some full remote employees. So it's about that size. So we also have some students. This is the question how you count them, but so it's roughly 20.
I think it's fair to fully count them. They're doing great work, and it's part of our mission also collaborating with academic research, right? And in that respect, then we are supervising thesis, mostly bachelor and master thesis, also some PhD thesis. That's also part of the game at the research lab.
It's crazy. I've been here since 2011. Obviously, since the time I was not even aware we had a research lab. Of course, I'm over here in the States, so that and in the sales side of things, so we don't get word of that. But it really amazes me. Are you too familiar with Bell Labs, the place that used to be in the United States? I was seeing head shake somewhat. Yeah. Yes. So for any listeners who aren't, I'm sure it's nothing like Bell Labs and all, but in a way it is, right? Bell Labs, for people who are familiar, Bell Telephone had laboratory in New Jersey. I think that's actually the building where they shoot Severance, is for the former Bell Labs. But they would just bring in researchers and scientists and let them loose with their imagination. Now, obviously, it sounds like you guys have a mission. It's a little bit more focused. But to me, the idea of having a research lab is just mind-blowing, which I don't know, it's just really, really cool. And as Andy said, or one of you said maybe, the idea that a company of our size having a research lab is also just, astounding too. So now I'm just excited about today's conversation, but I just wanted to get that in there because it sounds very reminiscent of when a company would take time to actually do a lot of research. I mean, it even goes back to, our approach with Grail, right? Let's build it ourselves. We need something that needs the capacity. We have smart people. Let's build it. So really, really cool.
And that actually brings me to the next question. I know that both of you're working on certain topics, but if you could quickly kind of give a glance on what are the key topics that are researched in that lab, just a quick overview, because I'm sure with 20 people and some additional students, there's a couple of topics.
Yes, there are 4 topics, or we have 4 research teams at the moment, and they cover 4 different topics. Of course, they are overlapping partially. So one is real-time analytics. This is the team which I'm leading. Then we have distributed data systems. Then we have generative analysis. This is what Martin is leading. And the 4th team is cloud-native security.
So all extremely relevant topics, obviously, right? I mean, let's jump into some of the details, because it was really great that we had some time to sit together yesterday over lunch. Maybe let's start with Martin. On your end, can you fill us in a little bit on what is the N+2 thing that you're currently working on? Even obviously you're working at academia, so I guess a lot of the stuff that you're working on will somehow also be publicized. But obviously, tell us what you can tell or what you want us to tell. But it would really be interesting just to know what you're researching on, your team is researching on, and what might be something that we will be able to see in the future.
Okay. Yeah, first, my team is still relatively young. When I joined 1.5 years ago, it was me plus one additional person, Selina. And over time, the team filled, and we are now 7 people in the team, plus almost the same number of students. So it has grown quite a lot. But we are still kind of trying to find exactly our path within the greater context of things. What we are currently mostly involved in, so you're all, of course, aware here of Davis Copilot, which is the Dynatrace generative AI offering. So in a nutshell, what it is, it's a natural language interface for customers to produce stuff, and that stuff can be a simple answer to a question. That's quite trivial. We know this. Chatbots, they are popping up everywhere. More interesting use case in our case is query generation, so generating DQL, Dynatrace query language queries, using natural language input. This is already in the product and generally available to customers. In the future, more and more things will be added. Like, I mean, this is all really future. There's no promise product roadmap-wise, right? But just some ideas. In the end, you could generate almost anything starting from a natural language prompt, dashboards, workflows, whatever you would like, complex actions, deep research-like things like Google, Anthropic, and others offer to solve really complex tasks over a longer period of time. All that, I mean, is in our minds already, but yeah, not much more than that, perhaps at this point. What we focus on at the moment are, mostly the topic of query generation. So when we started out, it was essentially around the time when I also joined. The decision was to go to market as quickly as possible. And so what we are leveraging here still now in the product is models from OpenAI, so GPT-4 models, together with some heavy engineering around it to generate these queries. And what we are working on is training our own model, our own Dynatrace model for query generation. That's already at a very advanced stage and delivering great results also in comparison to our baseline. And we are at the moment, the work is on integrating that into the product, but still at the same time, of course, continuously improving it. This is one of the topics. Then another big topic for the future is Agentic AI. So that covers potentially, of course, a lot of use cases, but the general idea is that you have more complex questions that require several steps of reasoning, plus some kind of tool usage, where a tool can be anything. That can be just generating a query, executing it, and consuming the output. It can be one of our Davis analyzers. It can also be something external. I mean, it can be Google search, right? It can be a calculator. It can be a code interpreter, code executor, can be anything. Yeah. And to be able to solve complex tasks that require several of these tools, potentially several reasoning steps, to answer more complex user questions in general, for more specific use cases. This is what our main focus is at the moment. A third smaller topic is in log analytics, how to group and then also explain, analyze, interpret logs or clusters of log messages.
I got a question now, and hopefully I'm not opening up a can of worms here, but it seems that obviously with LLMs and everything you just talked about, we can solve a very interesting problem, at least in our industry, and I'm sure in other industries as well, which is not being bound to a vendor, to a specific query language, to a specific way of creating dashboards, if you can just use natural language to get the answers that you need, right? So classical example is always, why use, I want to use an open standard, because I don't want to be locked into a vendor in their language, in their dashboards. And it seems for me that as these models evolve, we achieve this, and the natural standard, the universal standard, is the human language. And at least that's, if I hear this correctly.
Yeah, I think that's definitely a possibility. Of course, I mean, not all languages are equivalent. You might be able to do something with one query languages that you cannot do with another, and then there are still, even if it's transparent to the user, there are differences of what you can achieve. But in the end, for all of them, the input would be natural language, English, or any other language, actually. I mean, all our tools work equally well with all of the major languages. You can even serve to translate. I mean, we've, for example, seen if you translate, I don't know, from DQL to SQL or to some other query language, that may work in some cases not so well, depending on how well the LLM knows this language already from their training. I mean, SQL, of course, it knows a lot, DQL less so, and same for other more proprietary languages. But what may work quite well is first translating a query into natural language and then producing from that a query in another language. So to have this step in between, for example. Yeah. So absolutely, that's a possibility. Yeah. The question is what will be behind what the user sees? Will there be these languages, or will at some point maybe LLMs just create their own language to query data? And it's all far in the future, certainly, but lots of possibilities. Yeah.
Yeah, I was talking with some colleagues at our sales kickoff the other week, and I just recently learned about this idea of the AI agents, versus these other things, and it's still all a mystery to me. So I'm not going to talk like I know anything, but it really became apparent that the future state is you wouldn't even necessarily learn how to use your tool, right? You wouldn't have to learn the ins and outs of anything. You would just give it a prompt, say, "I want to see this. Do this for me." And at some point in the future, all the AI, the LLMs, everything working behind it's just going to be able to produce the output for you, which I think is just absolutely fantastic, right? There's been a lot of hype around, AI doing this and that, and we get like pictures missing pinkies and all this. But when you have these really deep tools, like even if you're thinking like on a cloud platform, I want to deploy an app on this and I want it to look like this, right? And it can do it all behind the scenes for you. Now, yeah, there's a lot of time and space between today and that. But the exciting thing that I think is that we also see a lot of these AI capabilities and features just exponentially changing even without warning, right? So, I guess where I would turn this into a question is in more of the research mind of it, not obviously product mind of it, in the research mind of it. Do you see a time soon when you'll be using other components of AI to help create what you're looking to create on your side, right? The behind the scenes stuff, right? Training models, right? Can you use AI to train an LLM, right? Can you use other things to do all these pieces? And how soon is it going to snowball into it can just start almost self-generating?
Yeah, that's an almost philosophical question. I mean, two things. A, I'm pretty sure we will get there at some point. B, I believe not in the foreseeable future. It will still take quite some time to get there, especially for more generic. I mean, the whole idea is also what's behind super intelligence and AGI, ASI, right, in a more generic sense. AI is just making itself smarter and smarter and overtaking us quickly and then enslaving us and I don't know what else. I don't know if it's going to happen. It's certainly a possibility, but I don't think.
Well, I don't even mean the enslaving, but the idea of when I was thinking about this the other day, allowing AI to start writing code, right? But then you would still think, okay, well, a human has to still verify the code, right? But then at one point, can you have another AI verifying the code, right? And then if the code is wrong, having yet another AI like write a fix for it, and then going through iterations of testing, collecting the telemetry, say from a Dynatrace or something, and looking at everything and being like, yes, this is working. It's going to make a judgment to say whether or not it's working as the input said it was going to work. So I'm not talking about, Terminator, which I know is from Austria anyway, right? So, but, using those cycles of how much do you replace, or when and how can you replace the human factor in it to accomplish the things that right now we think of, well, you still need the human there. And in most cases, you still need the human there. But at what time can that be replaced? And it sounds like it's still a ways off, right?
Yeah, different people have different bets. So if you believe some of the people in the Silicon Valley, it's more like a couple of months. I don't think so. I think it's more, definitely years, but more likely decades, tens of years. We'll see. At the moment, yes, you need humans for verification, but also I think it's still the case, even if you don't need to know all the details on how to use a tool, it still makes you a better programmer, architect, whatever, if you know how the underlying tools work, because only then can you really also prompt and even formulate a problem in an appropriate way to get the optimal solution. Quite definitely, at some point, we will get to the situation that you have described, that AI will be doing all these steps itself. What I'm not so 100% sure about, will it really be able to create something genuinely new? I mean, what it will be very good is recreating what already exists, creating similar things, interpolating between things that already exist, that can be code, but could also be art, right? I mean, you've seen our nice images and music pieces and so on, and they look like creativity. They look good, definitely. They produce nice music pieces. They also have some new elements in them. It's not like they're just copying things. But then the question is, okay, they can perhaps produce a new nice pop song that is in fact different to what we already have. But I don't know, if you feed them all the human music until the 19th century, some classic music, some, I don't know, native Black American music and so on, would AI be able to invent jazz, for example? Would they be able to invent blues and all this rock music? Definitely not today. We'll be able to do that in the future. So really, it is not just combining existing things, but creating something genuinely new. I think the jury is still out on that. We don't know that yet. And frankly, I think this kind of creating something genuinely new, this is relatively rare, even among humans, right? But still, the big progress always comes from this kind of steps. And my guess would be we will still be needing humans for that for quite a long time, actually.
And what's great to see is obviously all the work that you're doing in the research lab. We will hopefully then eventually benefit all from this, what you then bring into the products. Martin, I would have another question on Agentic AI, but I want to park it for now, because I also want to now switch over to Otmar. And give him a little bit of a chance to also talk about the stuff, Otmar, that you are doing in your team. So can you, similar to Martin, just quickly fill us in on the primary focus topic of your group?
Yeah, so as our team name is real-time analytics, so which means that we're focusing on processing huge amounts of data in real time. So, and we're really talking about data volume, which is really big. So we're talking about petabytes per day. So which, gives us a lot of challenges. And so we really have to be creative still. Yeah, let's wait for the AI maybe, but still we have to think ourselves how to solve these problems. And we are focusing on data structures, algorithms to handle these data volumes, but also we're looking into new technologies, stream processing frameworks that can handle that, and everything what is also associated with that, fault tolerance, scaling, and so on. So this is our main focus, and it's very exciting.
Yeah, and I think you've also done, contributions back to the scientific world, to the industry. Any examples that you can give here?
Yes, actually, we also looking for data structures to summarize data. One example is if you want to count distinct things, distinct users on your website, for example. If you want to know the exact answer, you have to remember all the unique IDs of those users. But there are data structures like hyperlog that can do that only with a fraction of the memory. So let's say a few kilobytes is sufficient to get an approximate answer of a few percent. And these algorithms are very exciting, and we were using them, and we saw that they can be further improved, and that's why we developed even better data structures, ultralog, exalog, which were finally presented at scientific conferences. This is one example, but we also have some publications testing different stream processing frameworks, defining a benchmark for stream processing, and things like that.
And so these, then your contributions, they make it to scientific presentations, papers. and they also then find it into software libraries, into open source libraries, or into how does this work? What's the process then to make so that this makes it into a final product or library?
Actually, we have also open source library. It's around hashing algorithms in general for Java, because we've seen that in Java there are only a few hashing libraries, and some are not really up to date and do not have implemented the latest hashing algorithms, the fastest ones. And so we decided to come up with a hashing library ourselves. It's Hash4j. It's on GitHub. It's in the meantime widely used in our product, but also in IntelliJ, and also Apache Pinot is using it. These are open source projects we're aware of. And we also have some smaller projects as well. This is one thing, how we distribute or maybe make our algorithms more popular.
Yeah, really exciting. And Brian, if you think about it, right, we often talk about performance in a completely different sense, on a different scale, like optimizing page load time from 2 seconds to 1 second. Right, this is really important. But thinking about hashing algorithms and then how you can squeeze out probably milliseconds out of those operations, and because they are used millions and trillions of time, and it's a completely different level now of performance engineering that we talk about.
Yeah, we're working at the physical level, and Otmar, you're working at the I was going to say nano, but I didn't want to say nano. What's the branch of study with wormholes and all that? The quantum level of performance, right? Obviously, it's not quantum mechanics, but it's like that level, because going back, I remember even working with someone on a high volume trading app, where like 1 millisecond of overhead was too much, right? You're probably looking at that and even smaller, right? I imagine.
No, we are not. We do not have to care about latencies like these trading companies. I think they really have to build their servers right close to the trade exchange, right? A stock exchange, sorry. And in order to have the delay as small as possible. But this is, I think, a different level. So we are not at that level. We can afford latencies that are much higher, but of course, our main driver are the costs. And of course, the less CPU you use, the less memory you use, the cheaper you can provide your service.
Yeah, there's a lot of that going. In fact, I was watching a video the other day where it ties that concept into AI. Well, obviously, cost is a big thing in LLMs and all that kind of stuff, but this was more about how to thwart learning from other people's music, right? How to thwart AI at learning from other people's music, because a lot of times they're just going out and grabbing people's stuff without permission. So they're building in this inaudible noise into the WAV files, which the AI chokes on and comes out with all these crazy things. But it takes about 45 minutes of heavy GPU processing to process about 15 seconds of music, right? So that's when you're talking about the cost, the time. So yeah, it's very different than milliseconds, but it's about efficiency, right? It really comes down to, and again, if I go back to Grail just for a moment, because that's something that I can more grasp my head on. And for anybody not familiar, Grail is our really crazy, fantastic backend. I'll leave it at that, because I'll do worse if I try to explain it. That was all about scale, efficiency, and all that. So this stuff obviously takes a lot of research to do, right? You can't just go from, we're going to use the typical backend and suddenly add, 20,000 data sources to it, because that'll collapse. And I'm sure you can build something that'll handle it, but at what cost, right? So it's that fine balance, which is, again, I'm in such awe that we have this research lab, because then you can do all these experiments and figure out what's going to go on. It's really awesome.
Otmar, I know you also had another topic. I want to also park it for now, but I think it's around sampling. I want to use this for later. But the segue now is perfect, because Brian, you talked about costs. Coming back to agentic AI, And one of the questions, Martin, that I had for you, and it also came up in the conversation we had yesterday over lunch, if you're building these agentic systems and really you are just, prompting, and then a system goes off and does 50 things with different tools, how do we know that what's been done is really efficient? How much does it cost? Who is involved? Is there any how can we control this, or how can we understand what's actually really happening? And especially around the cost factor again, is there any way to make sure this doesn't explode in our face at the end of the month or whenever the billing cycle comes with all these tools that are connected?
Yeah, I mean, usually the best practices around building agentic systems, they recommend to start with something relatively constrained, not giving the LLM too much autonomy, because that, I mean, it might be fun to do it, privately, to try it, see what happens, and amazing things might happen sometimes. A lot of nonsense might come out a lot of other times. But if you put it in the product for your customers to use, that it's robust is perhaps even more important than like the last per mil or percentage of quality of the result, right? So the idea is typically to start with some very constrained, almost workflow-like things where there's very little freedom, which covers a certain number of use cases and also requires a maximum of a certain number of calls then to LLMs or other tools. And only once you gain confidence in the whole system, you understand better how it works, you can slowly perhaps loosen it, give it more freedom, in a controlled way, step by step, so that as soon as you can see things going off, there's still time to react to do it, right? At the same time, there's of course kind of a bet going on in general, I think, in the GenAI and LLM industry, the idea that things will keep getting cheaper and cheaper anyway. So whatever is too expensive today, there is some point in the future where it will not be too expensive anymore. If that's true or not, we will see. Definitely in the last couple of years, I mean, costs have come down with respect to LLMs at a tremendous rate. I mean, Moore's law is nothing compared to that. It's much faster than that. I don't remember now the numbers from the top of my head, but if you compare from essentially, the first real usable LLM for industrial commercial applications with ChatGPT and GPT-3, GPT 3.5, it's only been now around for about 2.5 years, right? But if we see how much costs have come down in these 2.5 years, it's already been orders of magnitude. If the trend continues like that, I don't know how long it can continue like that, but if it continues like that for a while, things will get so drastically cheaper that a lot of the things that we can imagine today will be doable in the near future, and almost anything will be possible in some given time in the future. So many people have this philosophy, not caring too much about this cost aspect at the moment, just build it, maybe wait with releasing it or constraining it a bit, but at some point of time it's more important, it's powerful enough, the cost issue that will solve itself sooner or later anyways.
It reminds me a little bit. So I learned software engineering in the 90s. I went to HTL in Leonding. So that's for the non-Austrian folks. It's the higher technical high school, I guess, right, where I learned programming. And in those 5 years I was there, we started with assembler, right? It's kind of very low level. And then, but I remember in the Matura, that's kind of the graduation in the last class, we had the choice between either building apps in MFC or the second one was Oracle Forms, which was kind of almost like a 3-4GL language where everything was abstracted. You could just point and click and move things around, and then you got a very nice. And you have, right? It was so far, so many layers away from assembler, how we started, which is great. A lot of efficiency gains, but we had really no clue anymore what's going on. And it was an efficiency gain, right? And I guess what you were just explaining is kind of similar, right? We're betting that the underlying technology will get cheaper and cheaper, and therefore we're building abstraction layers. So we're making it easier for the end user to do things that they would not be able to do in the amount of time that now is possible with AI and agentic approaches.
Exactly, yeah. And at the same time of getting cheaper, also getting better, of course, right?
Yeah.
So not only a lot cheaper, but also a lot better and less likely to just derail into something that you don't want to.
Yeah. Otmar, I want to go back to you for the topic I teased earlier. OpenTelemetry is a big topic. We've been discussing this, Brian, in different episodes. The new standard that has evolved over the last couple of years in order to capture logs, metrics, traces. Now we also get profiling information in there. They're working on real user monitoring and other areas. You have told me that one of the topics that you have been, you've been part of the SIG for quite a while, correct? If I remember this correctly?
Yes, from since I think, or at least for 2 years, I guess. We're actually looking into how we can define the standards such that we collect the sampling information such that we can make use of the data or make use of the sample data, because it's not so easy if you just do the naive way and you sample and just collect the spans, and then you do not know at which probability the span was selected. Mm-hmm. And without this probability, you cannot extrapolate. Yeah, that's the problem. And currently, if you consume OpenTelemetry spans, they do not have this information on it. And this is one of the main reasons why we have this SIG. How to define that? I mean, it's one piece of information, but you can define it in various ways and more efficient ways and least efficient ways. So it's basically the probability, but you can also, for example, store it as a multiplication factor. This is the multiplication factor which you use for extrapolation and things like that. And some are more efficient than others, some representations.
Yeah. And for me, just like to recap what I learned, what kind of like was an eye-opener for me a little bit when we talked about this, because we take this for granted when we work with our way of instrumenting, what we've done with the one agent for many years. Our agent automatically starts sampling, but the data that I get back, if I say, how many requests did we have, I still get a very accurate number, even though we may only capture 10, 20, 50% of the traffic because we made certain sampling decisions. If I'm doing OpenTelemetry, you're actually working with the SIG, the special interest group, to also get this level of information captured on the trace. So if somebody says we're getting 100 transactions in per minute, but we're sampling on the rate of 10%, so that means we only get 10 in, and the backend system only sees 10, but the backend system has right now no idea, does 10 mean we get 100%? Do we get 50%? Do we only get 10%? Exactly. And how can I extrapolate this, right? And I think it's really cool that you in this particular instance are contributing to the open standard to also solve this problem, because right now this problem is not solved.
Yes, I mean, we're already quite far and hope that we get it into the spec finally. But of course, it's a lot of discussions, interesting discussions, and, a lot of pros and cons for every design decision. And so it's a very lengthy process.
Yeah. But for me, it was right, because in our industry, and I'm sure this is true for other industries as well, all the vendors, we're very proud of what we've built. There's a lot of money that went into building our IP. And so why share and why contribute and why collaborate now with other people in the industry? But this is a great sign where we say this is a problem that needs to be solved, because otherwise we cannot give accurate, or at least with a high probability accurate data, if we make our dashboards and analytics in the backend based on sample data and if we don't know the sampling rate.
Exactly.
Yeah, I also think, Andy, that ties into the whole community of IT, right? Where everyone shares a bunch of stuff, right? We're all proud of the types of agents and everything we've made because they didn't exist and they had to be created. And of course, for those of us who are passionate about performance and all this kind of stuff, our wish and goal is that everybody's taking performance seriously. Everyone's looking at how to run these systems. So if it gets to the point where collecting the data is easy for everybody, right? That gives all of us vendors and everything else the opportunity to really focus on with our customers how to consume that data, how to provide answers, how to lead it to better business and all that, right? Which is what, we ultimately do, right? Because collecting data is just data, even if you use our agent. It's how do you present it? How do you solve problems with it? How do you achieve business goals with it? And I know I'm sounding a little salesy here, but that's the main driver. And the more people that we get who can easily deploy an instrument without that cost barrier of the agent, at least, right? The more, like, again, not to sound stupid, but the better the world will be, because everything will be performing better, and you'll have less of those headache problems of, oh my gosh, I went to this site and it was so slow today and it was just awful and I couldn't click it and it wasn't working, right? It gives everybody a better chance to do it. So I think it's very much in line with the way at least the people in the IT community work. Whether or not the corporations, that's a different side, right? But obviously we're seeing that because there's a lot of big companies that are sharing to these hotel things. Anyway, I'm doing another rant, so I know we have only a few minutes left. Let me let you get back.
Yeah. And contributing to the data quality, right? In this case, it's critical data that we all capture, but Otmar and team, you're contributing to making sure that the data we're capturing based on these standards have the right data elements so that we have better quality in the end and can make better analytics. Brian, as you said, we're getting towards the end of the episode. I know there were some other topics that you mentioned earlier. You mentioned security is a big topic, and just a shout out also to Stefan Achleitner. We had a podcast with him already, I think it was last year, on cloud native security. So folks, if you're listening to this and you want to also learn a little bit more, what is the research team doing around cloud native security? There's a podcast where you can listen to one of our other colleagues. And what did I miss? I think there was which other topic did I miss? Of the topics.
Distributed data systems.
This exactly.
Distributed data systems, so definitely something for another episode to dive deeper into this. Final round, starting with Martin now. Martin, anything we have missed to mention that you wanna tell us in the last minute?
Yeah, so if anyone is interested in working with us from academic research students, they're very welcome, of course. We are always, doing a lot of interesting stuff, I think. With students, most of what we've discussed today is very close, actually, to our product or Davis Cobolot. With students, we always have the freedom to explore a bit more, risky research, let's put it that way. And we are open for almost any topic that we can somehow meaningfully connect, at least, to what we are doing. Yeah, we like to work with other people.
And the students will be counted as people, right?
Absolutely.
and
Some
we
of
will
them
again
work twice as hard as we do, actually. They should count as two people.
And we will make sure to link all the resources so that people know how to get a hold of you on the podcast description. Otmar, anything from you? Any final thoughts?
Yes, we are also welcome all the people who are interested in processing huge amounts of data, and maybe also something interesting, because Martin said we can build something maybe and wait until it's fast and cheap enough to run. But this actually does not work for us, because in future also we have bigger data volumes. So the problem scales actually with maybe the improvements of resources or CPU power and so on. So it will be always exciting, I guess. Of course, only until maybe the AI takes over. But we have a few years, I guess.
So it's kind of like the Windows operating system. The bigger it gets, the more memory it gets. And then the cheaper the memory gets, you need more memory to run Windows.
Somebody always needs the money, right? Brian,
Andy?
what do you think?
Oh, well, I was thinking this is awesome, and I'm glad we didn't get to all the topics today, because I definitely want to have you guys back, and I also want to see, between Andy and Otmar and Martin, if and when any new developments come up that you are allowed to share, any new exciting research stuff that you can publicly talk about or anything. I think this stuff is fascinating. I'd love to have you guys on whenever you have something you want to share, because this is the really exciting stuff, right? In computing, it's always been what's on the horizon that gets people excited and want to continue. Obviously, you're working on your now stuff, but to know that these really cool developments are coming up is just fantastic. And just really to all the students that are helping out there, if any of them are listening, thank you so much, because this is how we keep going so that we can finally get Skynet to come alive. I'm kidding, but yeah, that's it. Really, really, really think it's awesome that you guys came on today, and this is a big revelation to me. Andy, what have you got to say?
Last thing, thanks, Martin, for everything you've already contributed to Copilot, because that is a great help for us in the Dynatrace community. Also, Otmar, thank you so much for your work and contribution to OpenTelemetry. I know we also have ideas for doing a video on some of the things you mentioned earlier, the distinct value count once this becomes available in DQL. So we'll definitely see you. And yeah, that's it. I know it's the end of the day here in Austria, and I don't want to keep you from your evening beer or whatever you're going to do now on a Thursday evening. But thanks, and see you soon.
Yeah.
Thank you all.
Thank you guys. It was a lot of fun.
Thank you. Bye.